My name is Mantas, as you heard. Thanks for coming. Sorry in advance if I start talking like this, because I'm not used to multitasking like this and holding two pieces of my both hands. So I work for Uber. I don't know how many of you know who Uber is. Maybe someone already used Uber, not in Riga, unfortunately. Oh, yeah, it's not so many as in different places. Unfortunately, I can't answer the question when the Uber will come to Riga. I have no idea.
From next year.
I have no idea. Oh, you know. I don't know. We don't know. Okay, so my topic today is about metrics at Uber and how we're dealing with this scale, because we're collecting a lot of metrics, and how we do things. During my career, I spent a lot of time in different teams. I started from operational, was in research and development, was in purely development teams, then the SRE teams, DevOps teams, of course. And during my time at those teams, one thing happened. I fell in love with metrics. And you may ask, what the hell, why metrics? What's so important about those? So first thing, what metrics is, right? Metrics is measurements. Measurements, like in most simple form, it's like metric path, or what we are measuring, timestamp, when we're measuring, and value what we get during measurement. And measuring things, it's so masculine, right? Like, we like measuring things as a guys. We like comparing things. We like brag about size of our environments. We like to brag about, I have 2,000, 3,000 Docker containers, and my friend has only 2,000, right? So now I'm better. So size matters. Another thing, metrics actually, it's even like art. This is actually a picture I took in Modern Art Museum in New York. This metrics I taken from Wikipedia. Yeah, and it's put on the wall as an art. So you can see. Another thing, what I want to talk about, is have you heard what Lance Armstrong bug is? By the way, this guy is Lance Armstrong as well. So Lance Armstrong bug is when your code always passes all the tests, but it doesn't perform as expected, right? So this is Lance Armstrong bug. And one story I want to show, I want to share with you, true story from my work. It was before Uber. I just joined company, and the business guy comes to me and says, our site is slow. And I okay, so what do you mean slow? Was that slow? It's loading 10 seconds, 5 seconds, 2 seconds? What do you mean slow? And she says, no, this it just feels slow. And if you know that Trump is elected now in the US, the feeling is most important, right? Fact, it's not. So I just ask colleagues, there's no metrics actually. So I come back to my hotel, write some script, start measuring. And what I find out, it's the site actually loads in 40 seconds. 40 seconds, it's kind of slow. So I come back next morning in the office, we actually put more metrics on top of that. We pretty fast find out the core reason. We come to the developer and kindly ask them, because we found out what's actually slow. We come to the developer who wrote that, and he's what the hell? He actually says whoa, yeah, that's bad. So he fixes it in 2 hours. And actually, we got the site floating from 40 seconds to below 2 seconds, as I remember, in 1 day. That was insane. And metrics were all the key part of this. Metrics provided evidence what's actually slow, in which part is slow, and so on and so on. Of course, there are some strategies, just intentionally not to look into things, not to see things. But better strategies is, like Ois is saying, that if you can't see, you can't fix it. Right? So we prefer to see at Uber. At Uber, a bit about company I work for. It's actually still pretty young company, 7 years old. We operate in 6 continents, 72 countries, a bit more than 400 cities, have more than 1,000 engineers. So this one application, it's not so simple. Actually, funny enough, the guy today in the taxi, he was using Taxify. He asked maybe I know something about those applications, and apparently I do. So, so he asked me like how fast I can develop one and how much it would cost to him. Yeah, I had no answers to this. So we do like more than 5 million trips per day, and that's like each day what we do. The office where I come from, it's like Vilnius, Lithuania. You probably know where Vilnius is. So we have Uber engineering office in Vilnius. It's not so big, not such big team now. It's actually something like 30 engineers. We have 4 teams: observability, which does with the host level alerts, metrics, and monitoring. Databases team, who actually does like Postgres, MySQL stuff. Foundations, which I work for now. We're doing all configuration management for Uber, kernel stuff, and so on and so on. And development experience, those guys actually writing some tools which other developers use. Okay, so one thing which defines Uber as well, it's like intense growth. Unfortunately, I was forced to remove numbers, and you can see how fast actually this number of services grows. It's number of microservices at our company. It's now way below 1,000, or way above 1,000. So this is like insane growth of everything, like number of engineers, number of trips we serve, number of services we maintain. And knowing this context, where's the metrics at this part? So this is what numbers, what actually we retrieve. Sorry, I need some water. Okay. So we manage something like 500 million different metrics in our system. It's last time I measured. That means 500 million different pieces, different attributes, different values we get into our system. And this is, we're still growing like insane. This is 25% month per month growth. It's still insane, which we needed to deal with. Which is like, if you think about any system, which is like how you will deal with this. T0 service means that we treat metrics as a like most important service at Uber. Why we do this? Because if we lose metrics, we can't see what's happening. We don't know if it's Uber running or not running. We don't know any status of individual services. Important to know that at Uber, each individual development team are responsible for their own metrics. They're responsible for being on call for their own services. So if you lose metrics, because lots of monitoring is based on metrics, they just lose their monitoring and they go crazy. I don't know if you saw what's happening in the plane cockpit when they lose all the metrics in there, but pretty much the same happens with Uber engineering teams when we lose metrics. We just go blind. Go back to metric solution, what we have, what we had 2013. 2013, it's like still like three and a bit years ago. Uber was not such big. And all our metrics were collected into one server. It's not like I just was lazy enough and draw one server, but we're running Graphite. We're running, who's familiar with Graphite or who's like, okay, so for those who's not familiar with Graphite, it's like open source, commonly used metric solution. Corrigan cache, it's a service like Python service which running caches metrics a bit and writing into Whisper. Whisper is defined size database. So we were handling everything in one server, everything was working. But at some point when we grow, apparently it wasn't enough. So we needed to scale. And we scaled our Graphite installation something like this. It was 2015 when I took over our Graphite installation. Can I do this? Yeah. So we had written like HughMonitor service, which actually another Python service which runs and connects to like different sources like GMX, others, and collects metrics and reports it locally to the stats relay. We wrote stats relay initially because we start collecting so many metrics that we start killing our network with small packages. So the statutory work was like just buffer it before sending over the network. Then pretty much starts the installation. It's open sourced. We're using C version of it, like called StatSite. Nothing special here, and many of Graphite installations. Because our metrics, we need like to send them throughout the same path every time. We use like consistent hashing to get them to statsd and then into the Graphite. And everything actually starts to break. In that term, that engineers comes in and says like, I sent metrics, but my metrics isn't showing on a dashboard, and help me. So what you need to do is actually you need to look into this exact metric path, check every stage, look into the metric, see where the problem is, solve it, and so on. Those Python services like Carbon Cache, Carbon Relays here, they couldn't keep up. We needed like more and more services. We needed more and more storage space. So we start like putting more services and putting more shards into all this solution. The problem is we estimated how our growth, we estimated how many services we need. We start doing resharding, like that means copying like files, metric files to another services, new services, balancing everything. And we know our growth, so we actually over-provision our services, our servers, what we ask, like 2-3 times. But the problem is like in the middle of resharding process, we see that it won't end good enough because we will be not enough of servers because of our still growth. It's actually increased during the time we did our resharding. I don't know any successful resharding attempt, Graphite resharding attempt actually we emitted. So it wasn't good. We need to do something. And when you're in San Francisco, you actually has like ability to call to companies like Netflix. We called a couple engineers. Netflix open sourced their solution at that time, part of the metrics collecting monitoring solution. So we called engineers to give us like true story about Netflix, not like manager story what you give like on the shows, but like true engineering story what's good about this solution and could we use it. After 2 hours spending with them, we realized we couldn't use it because it was like very specific for them. It was very specific for usage on the cloud, and we stay on the bare metal, so it wasn't good for us. We looked to other solutions like InfluxDB. InfluxDB didn't have any scaling history at that time, and they didn't even have like ideas like how to do that. We looked into another solution which is called OpenTSDB, but we didn't like totally had experience with that. We looked into BlueFlat, and what it actually made really interesting for us, because BlueFlat was written in Rackspace by three engineers, 3 committers. 2 of them were already working for us. So we had like some experience with this. And what is more, it was based on, database was based on Cassandra, which we saw Cassandra as like good match for metrics. So we actually went on with BlueFlat. What we did, and this is like kind of note what we're trying to do right now, but kind of note for new applications development. The second day we started BlueFlat, we wrote this statchant part, which actually diverted metrics like production metrics. On the second day of development, we could like divert metrics to our testing solution, which was at the time BlueFlat. We could limit our metrics. We make sure that there's no back pressure on the production if we just close all that solution. So we start sending this. Statchant was like diverging metrics to ingester and indexer. Ingester part was like, this service was doing only one thing, sending metrics to Cassandra. Indexer part was indexing metric names into Elasticsearch. So when we query Elasticsearch for the ID of the metric, and then we get it from Cassandra. And what happened? It didn't perform as documentation said it should. So we called those 2 guys and said like, okay, what's happening? And those guys saying like, one of the first questions, they ask how many different metrics we collect. And I said like, oh, we're throttling, so something like, I don't know, 10 millions? And yeah, so, but I can change that if you want. They say like, right, so this solution was working for us, and this maximum what we are collecting, 1 million. And we looked at this point, and we understood that this is no way we can actually scale. We actually, the amount of code needed to be rewritten, it doesn't, meant we could actually expand the solution. So we decided to write our own based on that. We called our M3, our metric solution M3. All those services were written in Golang, ingester, indexer, and stanchion. So M3 solution, what we're using, it's pretty much based on this architecture of Blueflat. We still have ingester, which ingests data into Cassandra. We have indexer for indexing names. We changed our service, like we had this, we wrote M3 collector, which actually now not even buffers, but aggregates metrics a bit. We aggregate counters and gauges. We do not aggregate timers. This is different type of metrics. So then we still using statsd, sending everything to stats, and this is new service we wrote. It's called aggregator. The problem it solves when you send metrics in the different, in the exact period. Let's say you send metrics like every second, right? Like you have 1 second and you want to keep it like for a certain amount of time. But because you're sending so fast, you can't keep it long enough because it will take a lot of space. So at some point you want to aggregate them to the bigger chunks, let's say like aggregating like to 1 data point per minute. So what we did initially was this aggregator actually was reading metrics from Cassandra and writing them back to Cassandra cluster, which was not good enough because Cassandra is really great for writes and it's really good for reads. But if you do a lot of writes and a lot of reads at the same time, it just doesn't perform. So what we did then, we said like, okay, so we diverged metrics to ingester, which sends to Cassandra. And then we send them the same metrics to aggregator, which actually aggregates in metrics and send them to Cassandra clusters as well. We do not do reads anymore from Cassandra, which gives us a lot more performance. One more thing about when you do such thing, what helped us. This solution is totally backwards compatible with the graphite solution which was before. So our users didn't need it like to change their tooling, libraries, whatever. All this change happened behind the scenes. So that was really helped us with migration because users was totally blocked from this. Other thing, when we wrote our solution, like M3, we said like, okay, so now it's working. Let's onboard some real production services. Which services to pick? Let's onboard our own services. So we onboard our own services, start collecting metrics about our own solution, and then first or second day we have an outage. And suddenly we don't have metrics. And suddenly we, oh, fuck, what's happening, right? We can't even debug anything. So at that point realized that eating like your own dog food, it's not good for the metric system. So if you own metric system, open source or something proprietary, make sure you're collecting metrics about it with different system, right? That's key point. And make sure your metric system is more reliable than your services. And you know when something like alerts starts or there is gap in the metric, you for sure know that this is because of the service or it's because of the metric system not performing. Because that could be both, right? Metric system not performing, alerts fires, and you think your services are going crazy. But that's actually metric system. So you really need to distinguish between those two. So a bit about Cassandra, because this is like a key point when you choose like metric system like this. This is key point storage system to get it right. So Cassandra is like a figure of epic, tradition, and tragedy, and I like word tragedy actually. We had our growing pains using Cassandra. Actually, it's insanely great for writes. It's like we could push like insanely amounts to Cassandra. But when you scale, when it actually grows fast, you need to know how to manage it. You need to build operational experience from inside. There's nothing could help you. We hired some consultants. Didn't work. Didn't work. So yeah, why we picked Cassandra? High write throughput. Cassandra used data tier compaction strategy. It means how it manages SS tables, like data tables on the disk. We didn't need like to make sure when delete data especially. We had this TTL when the SS tables get dropped after some time. So Cassandra was really good pick. Other thing what we learned, we're not owning like one huge Cassandra cluster. We own a lot of huge Cassandra clusters. And this is done because we have data with different requirements. We have data which actually comes in and comes out, like should be discarded really fast. We have data which actually comes in, like said, like every minute, every 10 minutes, and should kept for longer periods of time. So this is like different strategies how you manage your data. So when we switched to managing more clusters, it actually improved our operational work and give us a bit of high availability, increase our high availability. Because if some Cassandra cluster even had some problems, we could switch load. Whoa, don't go there. Ah, no, don't do this. So we could actually switch metrics to another Cassandra cluster and query from that. So it was doing like this. By the way, that's interesting thing. We're still not happy enough with Cassandra, so the guys in New York start developing their own database for metrics. It's called M3DB, and it's developed in open source fashion. So if you want to look into this, you can actually grab it. Right. So another thing, it's querying. This is what we talked. It's like ingesting metrics into Cassandra. So now you need to query. Interesting fact was when we migrated from Graphite solution to the M3. Initial thought was like, okay, so now we need to copy all our metrics, not to lose history, from Graphite to M3. And Graphite stores its metrics in very small files, and lots of them. We wrote script, then another, and apparently in the best attempt, what we measured, it would take 2 months to copy all the files from Graphite to Cassandra. So apparently that doesn't work. So what we did, we didn't copy anything. We just said like, okay, so if you ask the metrics from some period of time, we just divert you to the Graphite, all solution, and you get it from here. And that's it. When we actually stop supporting this, like after some months, we could drop those servers altogether. For metrics visualizing, what we use, we're still using Grafana. This is currently we're running Grafana 2 something. If I would give this talk like in half a year, maybe a year, I bet we will go to something else than Grafana. We're not super happy with functionality of it right now, and we'll see how it goes with this. Another thing, when you do your metric system, and it's because internal system, and it's because guys just know, like development guys, operational guys, they just know, write this piece of code, or just send this metrics to some endpoint which they know, and it automatically appears on the dashboards, right? And it's because it's like internal, it's considered like free resource. And what happens with free resources? They getting abused. And they're getting abused in 2 different ways. One way is sending not correct metrics, which couldn't be even used. How it happens, someone wrote a part of code which sends metrics, or use some library which sends metrics. Other guys writing another service, they just copy that place from another like already written service to the new service, and hopefully it works. And of course it works, it sends metrics, but sometimes it sends really interesting metrics. Here it's metrics examples like check UID or UUID, right? It's like some number, IP addresses. I saw telephone numbers. Some insane things. They're sending like each metric, it's like unique. You can't even build like time series. You can't build dashboards. Nothing. That's not queryable anything. So this is not good. Another thing, how it's being abused because it's free resource. Remember, like if I tell you now, Amazon, AWS, it's free resource. Use it whatever you want. How do you think, how many virtual machines more you will have like suddenly, right? Because there's no need to delete. So that happens with the metrics. The guy says like, okay, I'm creating metrics. Probably I will need them at some point. Yes. That's like your wife asking like, I asking her like, can we throw this out? Or can we throw this thing? And she says, no, maybe we will need it at some point. Put it in the storage. My storage is like trash bin. Pretty much the same actually. So this is like guys do not treating us like they sending a lot of metrics. They think that it's needed. And one more example I can give you from this, Elasticsearch. Elasticsearch have indexes, and you can collect metrics about each individual index. And it seems like fine. And you can collect like hundreds of metrics about each individual index, and it's fine. But suddenly, when you have thousands of indexes, the number of metrics you collect just explodes, and you won't use them, except you start debugging some index. So we made the system that they can turn on developments or operational guys, they could turn on those debugging metrics when they need them, not sending them all the time. Our solution, how to prevent metrics abuses, how to lower number of metrics we collect, it's collect more metrics. Collect more metrics about metrics. We start collecting metrics, who's sending metrics, what metrics we are sending, which services, teams, and so on and so on and so on. And when we collect that data, we could actually go to the teams and show them, talk to them. We could actually even see which data being used, like that means in the graphs or in the alerts. So if they weren't used, like, and we see like large number of metrics coming in and that they weren't used, they weren't queried, we could actually talk to them and limit them or prevent them to sending if it goes to that. Another thing, it's like querying metrics. Graphite ways to querying metrics is to stack up all those braces and stuff. And it's not trivial for new engineers coming in who are not familiar with the syntax. It's not trivial to write queries to get metrics. So we wrote our own query language to query metrics. And from this point, it's already not compatible with the Graphite installation. This is already Uber's way of doing things. So this is more like what you do in your command line. You can actually predefine some variables. You can use pipes. You can actually put the metrics like with tags, put some pipes. And apparently, it's a lot more understandable for engineers to work with. So I can show you the difference, how we actually query metrics in the old way and the new way. So I don't know how to do that now. Let's try. Can you hear me? Okay, nice. Okay, so we have two metrics. Actually, one is like query the old way, and this is Grafana. And this is if you're not familiar with you write a query. I will try to write the query which is above. You need to know, you need to know some fields, which is actually we even predefining for all the engineers. For example, writing stats, which I need to know that exist. Or writing SGC, which is kind of data center. I even need to write the type of metric, which actually I've been looking. And just imagine, if I'm an engineer looking for metrics for some particular service, and that's not, oh, okay, that's nice. So, and if it's not, I'm not an engineer who's actually developed that service, I don't know what metrics actually to look for. So it's actually difficult for me to find it. Okay, so internet connection works. Hopefully. So when I need like to pass all the query string for this, and the service names comes like here, like mobile analytics, it's 4 or something. You need some agreements between across the company, how you send metrics and how you treat your metrics and how you look for them. So what we wrote, I just hopefully will be able to show you something. It worked before presentation, and now it doesn't. Internet connection. Can I try this one? Okay. If I can't, like, give me 10 seconds. If I can't, come on, come on, come on. No.
You can actually use the conference Wi-Fi.
Which one is that? What password? Can anyone?
On the wall.
Diffternity 216. Let's try this. I really want to show you like how we querying those. Okay, connected, not connected. And no, nothing happens. Hey. Okay, that should happen at some point. Whoa. Okay, so this is the impression how you, like, if you're an engineer who's not writing the exact service, but you need like metrics from that service. It's like difficult to find, right? Like you need to specially know what you're looking for and so on. So if I look for the new way, how we're doing like new way, and actually we patched a bit Grafana for doing this, and hopefully it loads. So this is already what you see. It's already our version like patches into Grafana. It's not open source, sadly. So, but now if you want to write a query like this, you don't care about which parts of the metric you actually look first. You just know, like, I'm looking for the service. So I'm looking, okay, I need some service. So I'm writing service, right? Service. So I'm looking for mobile analytics. And suddenly I could get like all metrics for mobile analytics. And I could actually define them even more. Because as you see, this thread says, like, I'm actually getting like more than 10,000 metrics at some point, which is like, we limit it. That's on purpose. That's hard limit, 10,000 now for querying. It's been for some time. So I can actually say like, okay, now I want like something like city. I'm choosing city, and I could choose something like Aarhus, right? And I'm just suddenly like going into this metrics, already know that I'm looking for metrics, which is actually for this current service. So this brings a lot more discoverability for the metrics. You don't care about the order you write queries, and this is, you get all the results. Then you can add those functions. Functions added like here, like you can transform null, you can do some series, some series, or moving sum, and that will work. That's part which we wrote, which part we're using right now to query and to show metrics with Grafana. Does it make sense? Okay. Okay. Cool. So another part, how the guys wrote initially, like a year ago, how they wrote the alerts. There was some Pythonish script they needed to craft. Then we had another script which takes this kind of script, converts it to real monitoring alert, put it into Nagios, and automatically it works, unless it doesn't. So you actually
sorry, you need this microphone.
Oh, okay, I forgot. As I said, I'm not used to like handling two things in one hand. Okay, so now they wrote this, like kind of script, which was input for another script, which actually made real alert and then put into Nagios, and then it works. It was good from perspective that it was really flexible. Guys could do any like sort of here, like query Zookeeper, get some results, then based on those results do something else, and we creating some kind of Nagios alert. Big problem is that every time you need to create it, it's like art doing this. And if you don't have the guy in your team who's doing that or used to doing that, you actually getting on the help all the time. And documentation had little help here. So we wrote another tool called HughMonitor, which actually visual tool. Now you wrote your query, like I was forced to blank it. So you actually write the query here, like yeah, like this, and then actually you get all the metric what you queried, you get into the screen, and you can see, you set your thresholds, and you can see if that alert would trigger it back in the history, how often, and so on and so on. So suddenly you have a lot more metadata, what you're actually trying to do and how it would work based on the historical data. So it was tremendous help for our engineers as well. Another thing, if you consider we have like 500 million different metrics, and we want like just having those metrics doesn't have any use. Like you can put them on the screens, but just maybe I'm from that breed that I can look in those dashboards all my day, and that's nice for me. But not so many engineers does. So we create, to make use of those metrics, we create alerts based on them. To create alert, you need metric which you need to look after, and you need to set some thresholds. And even if you take, like, if you say, like, I'm creating like on 1% of the metrics, or alerts on 1% of the metrics I collect, it's still huge number of alerts you need to create. And it was really manual process, even though it was some kind of scripted, but still really manual process. Setting thresholds, it's not easy. And at some cases, I'll show you, it could be really tricky to set correct thresholds. And even if you set thresholds, it doesn't mean you need to, like, to stop caring about those. You still need to constantly look into those thresholds and tune them. So we wrote another system. We tried to write another system called F3. F3 is like anomaly detection system, which we use like historical data. Let's say it's Thursday, 4 p.m., 5 p.m. We're looking back into history and looking for specific metric back into history, like how this metric looked like a week ago, 2 weeks ago, 3 weeks ago. Out of this data, using algorithms, we create some thresholds and set dynamic thresholds for that metric. And another thing, we didn't want to create like another user interface for our engineers. So we try to integrate everything into our Grafana slide. So here you go. Here you have metrics, which actually needs some alerts created for that. So now those thresholds being created and they're being pushed back into metric system. So you're able to show them. So you'll be able to draw them exactly on the same graph. So here it is like green, it's like metric, exact metric, and blue line, it's like upper threshold, and yellow line is like lower threshold. We do those calculations every 30 minutes. We predict how that metric should look like for the next 30 minutes. So we set those thresholds dynamically, and we catch alerts based on that. So if green goes like, hits any threshold, we get an alert. How to create alerts out of those? We create another function called anomalies. So the guys query the metric, they wrap it up into anomalous function, and anomalous function gives score from 0 to 10. Everything above 4 worth alerting. So it's really easy now to create any alert based on that, or like even like some script automation based on that. Another thing, when you get alerts, we are using PagerDuty. I don't know how many of you know what PagerDuty does. It's like third-party tool which you connect to. Its only purpose to inform your engineers when alert triggered, like by phone, text messages, push to your application, push to your phone. And PagerDuty really good at this, but it has problem. Or literally, it has many problems. But one of those, it is that just getting alerts, it's not enough. You need like to see trends based like on your alerts. You need to see what alerts actually coming in, which are actually like increasing, decreasing, what state it is. So we built another tool, and this tool is literally built in Lithuania. It's called On-Call Dashboard, which is like entry point for all on-call engineers for Uber. So they open the, when they go on shift, they open the shift, they see all the alerts coming in. That could be PagerDuty, that could be different sources as well. They are listed, and the important thing, you can actually tag those alerts. So you're solving them, and you tag them based on the reason why they're happening, and based on the solution or the measures you took on them. If the alerts are like useless. If you haven't done anything and they resolve themselves or just hanging it, but there's no real issue, you just like mark them as useless. And we can track how many alerts we actually get like useless alerts, how many alerts are actionable. We're constantly looking into those numbers, like from top management into this, and we are starting to improve this. Remember, it's like if you can't see the trends, if you can't see things, you can't improve. When you start seeing things, when you start drawing dashboards, and this data could be actually brought back to the Elasticsearch and visualized through Kibana, and we could see trends. So when you see, you try to improve, and that's what we do. Okay, that was my presentation for today.
Questions. Yeah, we do have some questions. Can you please give any examples of the metrics you collect?
Yeah.
Do you mix operating system metrics and application metrics in the same system?
Yeah,
What about business metrics?
Yeah, sorry, I just came like 30 minutes before before my presentation, and this was on my first slides. I needed to talk about this. The metrics I'm talking about here is like operational metrics from servers, like CPU, memory, basic stuff, and metrics from applications. How many users do we get? All the times between how long it takes from one application to call another application, how it performs, different performance metrics, all this kind of metrics we collect here. I'm not talking about business metrics here. Business metrics, it's very different how we handle them.
And you use different system for...
Yeah, we have different teams actually handling those, and we have different visualization for them. That's why I said, like, if I talk like year after that, probably we could import from the business metrics all this cool visualization stuff that they are using. The metrics amount of metrics they collect is less, and that's different, like different cases what they're solving. So.
Yeah, another question. Did you consider pooling metrics instead of pushing them?
No, we haven't. We haven't considered. We haven't considered this. We had this like graphite, HughMonitor graphite installation in place, and we didn't change the way we collect metrics at this point. That would be kind of big effort to do, and knowing all the integration we have. And basically, we wanted the smooth effort, like to bring new system into life, and not to bring all the effort for, like, push all the effort to our engineers to migrate to a new system. So we reused some parts, which was push.
Okay. For how long do you keep your metrics? Like a year, two?
No, it's different. No, we don't keep like them too long right now, and because like this growth, as I showed, and the amount of metrics which we're trying still reduce, but we keep them different. I think like longest metrics what we keep it something could be like a year now. I don't know. It's like maybe less now, maybe half a year right now. It's changing. It's actually we can change that dynamically, but different metrics we keep for different times. Like so there's.
Okay. Yeah, there are many questions.
Okay.
How would you compare your custom solution to a system like Prometheus, for example? Do you know Prometheus?
Yeah, I know Prometheus. I haven't used myself like extensively. I already saw it being used because our system, like at Uber, we're not saying like we created a metric system. Now everyone should use the same metric system. No. If your team is capable enough, and if you see that this M3 doesn't perform or doesn't satisfy your needs, you can actually use whatever you want. So I saw a team or two already using Prometheus. So I can't go into details into this because I don't know Prometheus very well. But it looked really promising what I saw. Like really, what I saw I really like. I don't know how it would scale in this amount. So.
Yeah, but at the moment, your teams don't have reason to switch to anything else. You're happy with what you have.
Yeah, so it's like, this is like team who supports metrics. So, but this like, as I said, like at Uber, we have like really a lot of teams. I don't know exact number, but a lot of. And I know only like one or two teams who are using Prometheus. Everyone else is using this. So it's like safe to say it's like 90, 95 maybe more in Uber engineering using M3.
Okay. Yeah, there's another question that I think everybody, well, many people are interested in. Why do you name your tools like M3, F3, and all that stuff? Why 3?
It's an interesting story because when I started working on this, we worked together. Like another guy who's now senior staff engineer, who was like main lead on this project. His name is like Matt Mihic. So Matt Mihic metrics makes them 3. Awesome, right? F3, we have girl who's like PhD, and she's behind all those clever algorithms, how we define thresholds dynamically. She's Fran. Fran, fantastic forecast, gets you F3, right? We have other systems because we're good at the names. Now we have P3, just don't ask how it goes. We have P3, probably something else. Unless we have some letters, probably we'll go on.
So it's a sort of tradition for your tools. Okay, another question. Do you have metrics for your source code? I guess like number of lines and commits, pushes, whatever.
I haven't seen them.
But I guess you do have them.
I don't know. I don't know.
But you produce the code as well. I mean.
Yeah, but I haven't.
You don't measure the code.
Yeah, but I don't know if you're collecting this kind of. I don't know. Like for real.
Okay. Yeah. There's a question. What about ES? Who asked that question? What is ES? Elasticsearch. Okay. It has anomaly detection. Do you use it? Do you like it, or do you plan to use it?
As I don't know, we haven't used it, and I don't know about
So
it.
yeah, again, you're happy with what you have.
Yeah, we cool at writing our own stuff. At some point, we wrote like a bit too much, so we'll see.
Okay. Yeah, think. Last question. Why your team has to make Grafana dashboard instead of developers creating the dashboards?
Oh, that's misunderstanding. Maybe I misspoke. The developers create. The developer teams are responsible for like emitting metrics, making alerts based on those metrics, being on call for those services, and creating dashboards for themselves, of course, as well. That's and they're not creating dashboards by hands as well. There's like tools, like scripts, which you actually like put input into those, and the dashboard will be created for you.
Okay. Any other questions? Yeah, there's a question.
Have you considered using time window compression strategy?
Which one?
Time window.
Time window for Cassandra?
Yeah.
From which version was available?
From 3 something.
Yeah, so it was not available at the point we started. Even data tier compaction strategy was actually implemented in 2.1, if I remember correctly, but then it was backported to 2.0, and we're using 2.0 for this. And data stacks, I can't say they backported to 2.0 because of us, but the day or the couple hours after they backported, we were using this in 2.0, but that strategy wasn't actually even available at the time.
Okay. Any other questions? Okay, then thank you. Oh, yeah, sorry, guys.
Do you visualize only using Grafana?
Visualize only Grafana?
Yes, or do you use anything else?
Currently, the Grafana is the main tool, yes. Do we visualize anything else? You saw already this HughMonitor, those guys making efforts by creating their own stuff, visualizing. We have some deprecated now tool called Grafanglia, which was a bit different. But mainly Grafana. Now we visualize mainly with Grafana, yes. We're not super happy about that, so I said like it probably will evolve into something. And I already see some efforts actually, guys want to change that.
Is some of the stuff you're improving Grafana, is it getting back to Grafana project? Because they implemented the alerting just right now, I think.
They implemented what, sorry?
Alerting.
Alerting from metrics, yes?
Yeah, Grafana.
That's,
Is that your stuff or?
no, that's working, and I haven't seen like anyone was looking into this because said like we're good at writing our own things, and I watched like I see already efforts to write our own dashboarding system, like moving out from Grafana. That's what the way we choosing actually.
But
I don't know how it will.
do you contribute back? Like,
No, this part actually what we did and what I showed you, it was actually considerate and talking with the guys behind the Grafana because they're based in New York as well. And I remember we had meetings, and initially we wanted for them to make this, and they say like it really makes sense, it's really great what we're doing, they really like it, but they didn't made it. So we made it ourselves, and how it's made, it's pretty much dirty. It's not, I think, open sourceable right now in the state it is. So that's how it is.
okay. I guess you can catch Mantas after the talk
Right.
during the day. And thank you very much.
Thank you for attending. Thank you.